The use of BeamAce begins by placing the device on the beam approximately 30 centimeters from the end of the beam. Before placing it on the beam, it is important to ensure that the jaws have been opened wide enough for the specific beam. Initially, the device's jaws move freely and can be adjusted by hand. Now is a good time to power on the BeamAce. Next, the jaws of the device are pressed against the beam by hand, which automatically aligns and positions itself in relation to the beam. The jaws are pressed against the beam so that both black support rollers on the left jaw and the metal measuring roller on the right jaw are placed against the beam. In this situation, the black support rollers on the right jaw are still a few millimeters away from the beam. The jaws are locked by turning the jaw-locking lever in the direction of the arrow on the lever. When the lever is turned, the measuring roller of the right jaw flexes inward into the jaw housing, and the black support rollers are pressed against the beam. The lever is turned until its tip reaches the mark indicating the lock position, and it stays in place when released. The jaws are now locked, but the locking mechanism allows for some flexibility, enabling the jaws to adapt even if the beam's width varies by several millimeters along its length. Now, the zero position in the longitudinal direction of the steel beam can be set for BeamAce. The standard way to set this position is to align the front reference surface with the zero end of the beam and confirm the position using the middle button. The zero position is always set by using the front reference surface on the same side as shown in the video. After this quick setup, BeamAce is ready for use, and the following real-time measurement readings and information are immediately visible on the display. These symbols indicate that the measurement mode that displays the position of the integrated marking tool's tip is currently active. This measurement mode is always automatically active when a new measurement is started. These measurement readings indicate the longitudinal distance of the marking tool's tips from the set zero position of the beam. When the front reference surface is aligned with the zero position of the beam, the marking tools are positioned at the distances shown in the video by the current measurement readings. These measurement readings indicate the distance of the marking tools from the edges of the beam, and this from the center line of the beam. BeamAce automatically detects the positions of the beam's edges via the jaws, so the zero positions of the edges do not need to be set manually. This measurement reading indicates the width of the beam at the current longitudinal position. This means that the device can continuously measure the beam's width and update the measurement readings accordingly. These are auxiliary measuring tapes that can be used to quickly find the desired width position for the marking tool. The upper measuring tape shows measurements relative to the beam's center line, and the lower measuring tape shows measurements relative to both edges of the beam. Red arrows indicating the position of the marking tools on the measuring tapes as scales. The idea is that the width position of the marking tools can first be quickly set visually close to the desired measurement, after which the final position can be fine-tuned according to the measurement readings. These icons describe the function that is executed when the corresponding button is pressed. The principle is that if the icon representing the function has a dark background, the function is executed with a normal button press, and if the icon has a colored background, the function is executed with a long button press. That is, the button is held down until the function is executed. In certain situations, one button can have two different functions simultaneously, one executed with a short press and the other with a long press. In the situation currently shown in the video, the top button can be used to start the temporary zero-point function, the middle button opens the menu, and the bottom button switches the measurement mode from marking tool measurement to reference surface measurement. Setting the target longitudinal position begins by pushing the device along the beam while observing the measurements readings indicating the longitudinal position of the marking tools. When the position of the marking tool with which the marking is to be made is close to the target measurement, the final fine-tuning can be performed as shown in the video by pressing down on the longitudinal fine adjustment hand wheel while simultaneously rotating the wheel. When the measurement reading matches the target value exactly, the longitudinal position is set. The setting of the lateral position is initiated by pushing either of the tool holders while simultaneously observing one of the measurement readings or measuring tapes indicating the lateral position. When close to the target measurement, the final fine-tuning can be performed using either of the lateral fine adjustment handwheels. Now that the target position has been set both longitudinally and laterally, a point mark can be made at that location by striking the marking tool with a hammer, causing it to function like a center punch. During the strike, care should be taken to ensure that the motion is as vertical as possible and that the hammer hits the center of the marking tool as accurately as possible. The hammer doesn't have to be heavy. The size shown in the video is ideal for BeamAce and helps you control the strike more easily. In addition to a point mark, longitudinal and lateral alignment lines can also be marked using the integrated marking tool. When making lateral alignment lines, first set the longitudinal position of either marking tool to the location where the line is to be made. Then place your thumb on top of the marking tool and the fingers of the same hand on the side surface of the marking tool holder's body. With the other hand, grasp the tool holder on the opposite side and begin pulling laterally with both hands while pressing the marking tool against the beam surface with your thumb. Care should be taken to avoid accidentally pressing the body of the marking tool holder against the beam, as this can hinder movement. When making longitudinal alignment lines, the principle is the same. First, the lateral position of the marking tool is set to the location where the line is to be made, after which the device is pushed forward from the tool holder while pressing the marking tool against the beam surface. Marking longitudinal alignment lines is easiest when the direction of movement is always from the marking tool being used toward the other marking tool. By marking both a lateral and a longitudinal alignment line, an alignment angle is created, which gives the part to be attached or the work to be performed the correct longitudinal and lateral position, as well as squareness or parallelism in relation to the beam. The longitudinal and lateral movements are designed to move effortlessly, but also to remain firmly in place once set. This makes it easy to move in only one direction at a time, ensuring that the other direction stays fixed. The stiffness of the longitudinal movement can be adjusted with an Allen key through the hole in the device's housing. For example, if the device does not stay in place longitudinally while making a lateral alignment line, the stiffness of the longitudinal movement should be increased. In addition to the integrated marking tool, markings can also be made using the reference surfaces of the marking tool holders' bodies. By pressing the lowest button for a long time, the measurement mode switches from the marking tool to the reference surfaces. When the measurement mode changes, lines appear around the marking tool symbol on the display, and the measurement readings are updated, indicating that the reference surfaces of the marking tool holder are now being measured in relation to the beam. In reference surface measurement mode, longitudinal and lateral alignment lines can be marked at target locations using a separate scriber against the front and side reference surfaces. When making markings, it is recommended to press the marking tool body against the beam to ensure it remains firmly in place during the process. In reference surface measurement mode, the longitudinal measurement readings always indicate the position of the front reference surfaces of the marking tool holders. While in the lateral direction, the measurement can be switched between the left and right reference surfaces with a short press of the lowest button. When switching from one side to the other, the measurement readings are updated automatically. By pressing the lowest button for a long time, you can return from the reference surface measurement mode back to the marking tool measurement mode. By pressing the top button for a long time, you can activate the temporary 0-point feature in both measurement modes. This feature allows the creation of temporary 0 points in both the longitudinal and lateral directions. It is particularly useful in situations where drawings only show the distances between holes or parts to be attached, and not the distance to the zero end of the beam. Temporary 0 points do not affect the normal measurement readings. They function independently. The operating principle is that temporary 0 points indicate displacement from the point where the temporary 0 point was set. The physical reference for the 0 point on the device can be the marking tools, the reference surfaces, or the corners formed by the reference surfaces, regardless of which measurement mode is active. The desired physical reference of the device is placed at the point to be set as the temporary 0 point, and the temporary 0 points are then activated or reset. The left measurement value indicates the longitudinal displacement, and the right measurement value indicates the lateral displacement. The arrow next to each measurement reading shows the direction in which the measured distance has been offset from the set 0 point. When the temporary 0 point feature is activated, a second function also appears on the top button, allowing a short press to reset the temporary 0 points and a long press to deactivate the function. Measuring with BeamAce on the Beam web is just as easy as on other surfaces. After slightly pulling the telescope release and bringing the marking tool holder body to the Beam web, all the same measurement readings and functions are available for marking on the Beam web. When the marking tool holder body is lifted, it automatically locks into the upper position. Even when the marking tool holder body is locked in the upper position, it retains a small vertical range of motion. When moving the marking tool holder body over the edge of the beam flange, both bodies should be lifted to the top of their range of motion and moved onto the flange. This allows longitudinal positions to be marked on the edge of the beam flange using a scriber against the front reference surfaces, or even on the vertical sides of the beam using the TS300 tool. As shown in the video, the TS300 is placed against the beam surface and the front reference surface. Used this way, the TS300 enables the marking of right-angled alignment lines at the target longitudinal position on both vertical beam surfaces. The TS300 has two separate surfaces against which lines can be marked with a scriber, depending on whether the longitudinal position was set using the marking tool measurement mode or the reference surface measurement mode. If the position was set using the marking tool measurement mode, the line is marked on the outer surface, which in this case aligns with the marking tool. If the position was set using the reference surface measurement mode, the line is marked on the inner surface, which aligns with the front reference surface. In addition to perpendicular alignment lines, the TS300 can also be used to mark longitudinal alignment lines at a specific distance from the beam edge. The TS300 has slots at millimeter intervals, and by placing the scriber into the slot corresponding to the target distance from the beam edge and pulling it along the beam, the TS300 can be used like a parallel scriber. When finished, the jaw lock is released by turning the locking lever further in the direction of the arrow on the lever until the tip of the lever reaches the mark indicating the lock release position. Then, the lever is returned to its starting position. The lever should never be pushed clockwise. Movement in this direction is always driven by the lever's own spring force and should be guided by hand, as shown earlier in the video. When the jaw locking lever is in its starting position, the jaws are freely movable again and can be opened by hand, after which BeamAce can be lifted off the beam. The safest way to store BeamAce is to place it in its case after use. However, when BeamAce is in continuous use, it can also be placed on the table dock between measurements. On the dock, the device's weight is properly supported by the bottom rollers and not the jaws, as would be the case if placed directly on a table. Placing the device's weight on its jaws should be avoided. When the jaws are positioned against the dock can conveniently be transported with the device. Charging BeamAce begins by opening the protective cap of the charging port and inserting the cable properly. When the device is on, charging can be confirmed by the lightning symbol on the display. However, after verifying charging has started, the device should be turned off during charging. By inserting the pads included with the device into the dock as shown in the video, a maintenance platform is created. The device can be placed upside down on this platform, making it easy to inspect and clean the measuring and support rollers. Thank you for watching this BeamAce training video. Please also make sure to read the BeamAce user manual carefully before using the device.